Class 9. Subject Chemistry. Chapter 2 is Matter Around Us Pure. Module 1. Objectives. At the end of this session, you will be able to define pure and impure substances, differentiate between homogeneous and heterogeneous mixtures, list the properties of mixtures, define solution, list the properties of solution, and identify the types of solution. How do you decide the following things that we buy from the market are pure? Have you ever noticed the word pure written on the packs of these consumables? For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For example, milk is actually a mixture of fat, water, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. A pure substance is one which is made up of only one kind of particles. These particles may be atoms or molecules. In other words, a substance is a pure single form of matter. If we observe some soil and some sugar placed on two different sheets of paper with a magnifying glass, we will find that the color, shape and size of all the particles of sugar are same. But the soil contains particles of different colors, shapes and sizes. For example, the soil contains clay particles, some grass particles and even some dead insects, etc. Now, sugar which contains particles of only one kind is called a pure substance, whereas soil which contains particles of different kinds is called an impure substance or mixture. From this, we can conclude that all matter around us is not pure. The matter around us is of two types, pure substances and mixtures. The mixtures are impure substances. Here is a schematic representation of the different types of matter. Matter can be classified into two, pure substances and mixtures. Pure substances can be further classified into elements and compounds. Mixtures can be divided into two, homogeneous mixtures and heterogeneous mixtures. Impure substances. Mixtures. A mixture is one which contains two or more different kinds of particles, or a mixture contains two or more pure substances mixed together in any proportion but not chemically combined. For example, salt solution is a mixture of two pure substances, salt and water. Milk is a mixture of water, fat and proteins, etc. Some of the examples of the mixtures are sugar solution, milk, sea water, air, sugarcane juice, soft drinks, rocks, minerals, petroleum, LPG, tap water, tea, coffee, paint, wood, soil and bricks. Types of mixtures. Based on the distribution of the particles in a mixture, there are two types of mixtures, homogeneous mixtures and heterogeneous mixtures. Let us see what are homogeneous mixtures. Those mixtures in which the substances are completely mixed together and are indistinguishable from one another are called homogeneous mixtures. Or homogeneous mixtures are mixtures in which various constituents are mixed uniformly. A mixture of salt and water is a homogeneous mixture as it appears uniform throughout. Brass, salt solution, alcohol are some other examples. Now let us see what are heterogeneous mixtures. Those mixtures in which the substances remain separate and one substance is spread throughout the other substances as small particles, droplets or bubbles are called heterogeneous mixtures, or a mixture in which various constituents are not mixed uniformly. The mixture of sugar and sand is a heterogeneous mixture because different parts of this mixture will have different sugar sand compositions. Examples of heterogeneous mixtures are iron filings and sulfur, concrete, which is a mixture of water, sand, cement, etc., chalk and water mixture, muddy river water. Properties of mixtures. The composition of a mixture is variable. The constituents can be present in any proportion by mass. A mixture does not have a definite formula. A mixture can be separated into its constituents by the physical processes like filtration, evaporation, sublimation, distillation, solvents, magnet, etc. A mixture shows the properties of its constituents. Energy is neither given out nor absorbed in the preparation of a mixture. A mixture does not have a sharp melting or boiling point. Take 3 beakers with 50 ml of water in each. Add a spatula of sugar crystals to beaker A, a spatula of powdered chalk to beaker B, and a few drops of milk to beaker C. Stir well with a glass rod. Particles can be seen in beaker B but not in A or C. Direct a beam of light from a torch through the beakers A, B and C and observe each beaker from the front. The path of light is visible in case of B and C but not in A. Leave the mixtures undisturbed for some time. Now filter each of the mixtures. You will find residue on the filter paper for beaker B. The mixture in the beakers are of 3 distinct types. The mixture in A is a solution, the mixture in B is a suspension, and the mixture C is a colloid. What is a solution? A solution is a homogeneous mixture of 2 or more substances. For example, a salt solution tastes the same throughout. A solution has a solute and a solvent as its components. The component of the solution that dissolves the other component in it, usually the component present in large amount, is called the solvent or the liquid in which solute is dissolved. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute, or the substance which is dissolved in a liquid to make a solution is called solute. For example, salt solution, sugar solution, vinegar, metal alloys such as brass and air. Now let us see what are the properties of solutions. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nanometer in diameter, so they cannot be seen by naked eyes. The particles of a solution cannot be seen even with a microscope. The particles of a solution pass through the filter paper, so a solution cannot be separated by filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. A true solution does not scatter light. This is because its particles are very, very small. Now let us see what are the types of solutions. Usually we think of a solution as a liquid that contains either a solid, liquid or a gas dissolved in it. But we can also have solid solutions, that is alloys, and gaseous solutions, for example air. The various types of solutions are solution of solid in a solid. Metal alloys are the solutions of solids in solids. For example, brass is a solution of zinc in copper. Solution of solid in a liquid. This is the most common type of solutions. Sugar solution and salt solutions are the solutions of solid in liquids. A solution of iodine and alcohol, known as tincture of iodine, has iodine solid as the solute and alcohol liquid as the solvent. Solution of liquid in a liquid. Vinegar is a solution of acetic acid in water. Solution of gas in a liquid. Aerated drinks like soda, water, etc. are gas in liquid solutions. These contain carbon dioxide as solute and water as solvent. Solution of gas in a gas. Air is a mixture of gas in gas. Air is a homogeneous mixture of a number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities.